Now let's solve some numericals based on this rate of reaction. The sum numerical which is asked in main or advanced exam. The reaction is same. Suppose I am considering N2 plus 3H2 gives 2 moles of ammonia. The question is asked like, suppose if the rate of consumption of hydrogen is 5.1 into 10 raised to minus 2 molar per second. Then question number A, what is the rate of consumption of nitrogen? Once they ask rate of consumption of nitrogen means I can say minus dN2 by dt we have to calculate. What is the formation of ammonia? That means we have to calculate dNS3 by dt. And the third question is C, that is what is the rate of reaction? That means we have to calculate speed of reaction also. Now say for the same question, we can answer directly also. 5.1 into 10 raised to minus 2 molar per second, this is the speed of the consumption of hydrogen. How many moles of hydrogen is consumed? I will say 3 moles. Nitrogen, how many moles? 1 mole. So if the 5.1 is for 3 moles of hydrogen, then for nitrogen it is going to be 1 mole. So it is going to be 1.7 into 10 raised to minus 2 molar per second. That is 1/3 of this. With what speed ammonia is forming? Simply I will say this is for 3 moles. So for 1 mole it is 1.7 into 10 raised to minus 2 molar per second. So for 2 mole it is going to be 3.4 into 10 raised to minus 2 molar per second. Rate of reaction is always written for 1 mole of component. So rate of reaction is again going to be for 1.7 into 10 raised to minus 2 molar per second. Now let's say how to solve. Better first write the rate of reaction for this particular reaction. So rate is equal to, because through the rate we can relate all the components together. So it is going to be minus dN2 by dt. It is equal to minus 1 by 3 dH2 by dt. It is equal to half of ammonia dNS3 by dt. So we got this relation. We have the rate of consumption of hydrogen, means we know this value and we have to calculate other 3. So if this is 1/3, so I can say minus dN2 by dt. It is equal to minus 1 by 3 dH2 by dt. In such reaction, don't cancel minus sign because minus sign have some meaning like consumption. So no need of cancelling it. So it is going to be 1/3 of H2 consumption is 5.1 into 10 raised to minus 2. So directly I can say answer is going to be 1.7 into 10 raised to minus 2 molar per second, because again it is a speed, that is the rate of reaction. I got this. Then second we have to calculate dNS3 by dt. dNS3 by dt is this one and this. Compare these two, or you can compare this with this dN2 by dt also. So dNS3 by dt, half of dNS3 by dt, it is equal to 1/3 times minus 1/3 times of dH2 by dt. So here I can say 2 will come to this side. So 2/3 dH2 by dt is 5.1 into 10 raised to minus 2. So it is going to be cancellation. This will give you 1.7. So 17 2s are 34. That means it is 3.4 into 10 raised to minus 2 molar per second. The third, we did this first. This is the second one, and the third we have to calculate the rate of reaction. So rate is equal to, consider any of these 3. So let I am considering the simplest one, that is minus dN2 by dt. The coefficient of nitrogen is 1, so the speed of reaction and the speed of consumption of N2 is going to be same. So nitrogen consumption is 1.7, so rate is also equal to 1.7 into 10 raised to minus 2 molar per second. So this is the way how we can solve such type of numericals. But simply if I know the concept, like the relations, then there is no need of solving this also while solving MCQs. We can write answer directly also. There is another example, N2O5 is where the N2O5 is decomposing to NO2 and O2. Again, the given part is the rate of decomposition of N2O5, which is given as 1.8 into 10 raised to minus 3 mole per liter per minute. So here the time is in minute. We have to calculate the rate of formation of NO2 and O2 for the same time interval. So ultimately, the formation of NO2 means we have to calculate dNO2 by dt, and the rate of formation of O2 we have to calculate, it means we have to calculate dO2 by dt. So to find the first one, we have to calculate the rate of formation of NO2 and O2. So again, simply I will say first write the rate of reaction. Rate is equal to, in terms of this, coefficient is 1, so it is going to be same, minus dN2O5 upon dt. It is equal to half of dNO2 by dt, or it is going to be half of 1 upon 1 upon 2 dO2 by dt, or I can say it can also be written as 2 times of dO2 by dt, means in terms of oxygen. Okay. Now let's write the rate of reaction. Directly first, let us calculate the rate of reaction directly. We have the rate of decomposition of N2O5. This, it means we have for this. So what will be the rate of formation of NO2? So rate of formation of NO2 is for 2 moles. So answer is going to be double of this N2O5 because the ratio is 1:2 and this is half. So double. Double means it is going, then it will become 1.8 into 10 raised to minus 3 into 2. That is 3.6 into 10 raised to minus 2 mole, 10 raised to minus 3 mole per liter per meter per minute. If I'm talking about the rate of formation of oxygen, then rate of formation of oxygen, the ratio is 1:half. That means whatever the speed we are having for N2O5, it's a half will be. This will be half. So half of 1.8 into 10 raised to minus 3. That means it is going to be 0.9 into 10 raised to minus 3 mole per liter per second per minute. Now let's solve. Better you find out the rate of reaction. So rate is equal to, I can say it is minus dN2O5 upon dt, that is equal to 1.8 into 10 raised to minus 3 mole per liter per minute. Now the rate is always for the 1 mole of the reactant or product. So here we have to next calculate the rate of formation of NO2. The rate of formation of NO2 means dNO2 by dt. So dNO2 by dt, it is going to be for this for 2 moles. So it is going to be twice of rate. So twice of rate, that means twice of 1.8. That means it can be written as 3.6 into 10 raised to minus 3 mole per liter per minute. Then we have dO2 by dt. The coefficient of dO2 by dt is half, so it is half of rate. Half of rate means half of the rate of reaction is 1.8 into 10 raised to minus 3. So can be written as 0.9 mole per liter per minute.